This is the 8th question we have in hand. There's some formula given here of x as a function of time. So here we have two constants k0 and k1. The first thing is that do not get scared by these equations, because the more difficult the equation seems, the more easier the question is. So here we need to find, the question is that we have to find out the dimensions of k0 and k1. So while looking at this question, we find out here that we have a term of e ki power minus k1t over here. Now e ki power, there is always a constant for e ki power something. When there is e ki power something, that something has to be a constant. So this k1t is a constant, but t has a unit seconds. It has the dimensions of time. So what we need to keep in mind that this quantity k1t is dimensionless. It is m0, l0, t0. Now the dimensions of k1t is equal to dimensions of k1 into dimensions of t is equal to m0, l0, t0. So that the dimensions of k1 is equal to m0, l0, t0 divided by dimensions of t, which is t. So we get the dimensions of k1 as m0, l0, t ki power minus 1. So this is our answer for the dimensions of k1. Now we need to find out the dimensions of k0. Now we see here that this whole quantity is dimensionless. So the dimensions of k0 upon k1 will be the dimensions of x, which is length. So xt is equal to k0 upon k1 dimension wise. So xt has the dimensions of length. So we can write this as m0, l1, t0 is equal to dimensions of k0 upon m0, l0, t minus 1. So the dimensions of k0 become m0 multiplied here, it becomes m0, l1, t minus 1. So this stands as the final dimensional formula for k0. So this is the final dimensional formula for k0 and the final dimensional formula of k1. We found out the dimensional formula for k0 using the dimensional formula for k1. So we first needed to find out the dimensional formula for k1.